In this video we're going to be learning how to factorize algebraic expressions. So we're going to be using a couple of examples to illustrate how we factorize algebraic expressions. Let's start with the first example. In the first example we want to factorize the following. So we're going to start with part A, where we have 5a plus 15ab, and on part B we have 12mn squared minus 8mn. Alright, so let's go on to the solution. On part A we have 5a plus 15ab. So the question is, how do we factorize? We first look for the highest common factor of the terms. So here we've got 5a and 15ab. What is the highest common factor? The highest number or highest term divisible into 5a and 15ab. Alright, so our highest common factor in this case happens to be 5a. So we divide the 5a into our expression. That's what we do next. So here I'll be dividing 5a into 5a, and what we get there is 1. Again I divide 5a into 15ab, and what do we get? 5 into 15, that's 3, and a cancel out, so what we get right there is plus 3b. So that is our solution right there. We are through factorizing. So we get 5a multiplied by 1 plus 3b in the bracket like that. So that's our solution for part A. So that's the simple thing what we do when you want to factorize algebraic expressions like the ones we have. You first look for the highest common factor. Alright, part B has 12mn squared minus 8mn, like that. So we want to factorize. So what did we say? First look for the HCF, the highest common factor. Alright, so what is our highest common factor for 12mn squared minus and 8mn? Right, so for the numbers for 12 and 8, the highest common factor for those numbers obviously is 4, and for m and m here we have m, and for n squared and n, the highest common factor will be n. So we have our highest common factor being 4mn, and next we divide 4mn into each of the term. We divide 4mn into 12mn squared. What do we get? We get 3n. We divide 4mn into minus 8mn. What do we get? We get minus 2, like that. So our solution comes out as 4mn multiplied by 3n minus 2. So I think you are seeing here the simple procedure with factorization. The key thing here is to first look for the highest common factor, the HCF, and when you find the HCF, you now divide it into each of the terms so that your algebraic expression is factorized. Okay, so let's move on to example 2. Right, so for example 2, we have an example. We want to factorize the following, starting with part A, where we have 9x cubed plus 15x squared y squared plus 3x squared y cubed, like that. And part B we have p plus q bracket p minus q plus p plus q bracket squared. So that's what we have for example 2. Right, so I know you want to try this one out, so I'm gonna give you just 3 minutes to factorize part A and also part B. So you may pause the video starting from now. Here's the solution. Starting with part A, where we have 9x cubed plus 15x squared y squared plus 3x squared y cubed. Right, so the first thing here, if you look at our terms here, we can see that we can have a highest common factor, because we say that's the first step, to see if you have the HCF, the highest common factor. What is the highest common factor? Let's start with the numbers. We have 9, 15 and 3. What is the highest number divisible into 9, 15 and 3? The answer is 3. And terms in x, we have x cubed, x squared and x squared. What is the highest common factor? Obviously it should be x squared. That is the highest term in x divisible into each of these three algebraic expressions. Let's go to terms in y. Here on 9x cubed we have no term in y, so it means that we have no factor, a common factor for the terms in y for all these three examples, three algebraic expressions that we have right here. So our highest common factor in this case is 3x squared. Divide 3x squared into each of the terms. Starting with 9x cubed, we get 3x. Divide 3x squared into 15x squared y squared, what we get is 5y squared. And divide 3x squared into 3x squared y cubed, what we get right there is y cubed. Right, and that is the solution. We cannot factorize it any further. Alright, let's go on to part B. On part B we have p plus 2q bracket p minus q plus p plus 2q bracket squared. Right, so if you look at this algebraic expression, though it looks a bit big, but it's not. You see here that we've got two terms here. We've got this one here and this one here, and the highest common factor, as I am seeing, is p plus 2q, because p plus 2q is common. We are finding p plus 2q over this side. We also have p plus 2q over that side. So the highest common factor in our case, the common bracket p plus 2q, that is the one we factor out. So that is our highest common factor appearing on this part of the expression and this part of the expression. Alright, so we divide, next we divide p plus 2q into this part. Right, so what we get is p minus q, because p plus 2q will cancel out, so that we are left with only p minus q. And we divide again p plus 2q into p plus 2q squared, and what do we get? We get p plus 2q to the power 1, which is p plus 2q. And next we simplify what's in the second bracket, so we get p plus p, we get 2p, and minus q plus 2q, what we get is plus q. And that is the solution to part B.